The Tower of Hanoi problem is kind of a classic recursion problem in computer science. Um, I don't know that it's necessarily going to unlock a amazing strategy for you to use in recursion, but it's fun and it feels like something that you should be exposed to if you really want to be serious about computer science and recursion. At least a checkbox to say, yeah, I looked at that at one point. So that's kind of why I want to create this video. Um, so maybe you've seen this before. It's kind of based off of a child's toy, a child's game, or the game Child's Toy is based off of the Towers of Hanoi, perhaps. Um, but the idea is I have three posts, and I have a bunch of disks that slide onto that post. And the rule is I cannot put a smaller disk below a bigger disk. The smallest disk has to be on top. But I can move these disks one at a time to a different post. And so the way we're going to define this problem is we have a starting post and a destination post. So we want to move 1, 2, 3, 4, and 5 from that starting post to the destination post. And the support post allows us to hold them in the meantime. So at the end, all 5 disks would be on the right and no disks would be on the left or in the middle, the flip of what we're seeing right now. So the process for this seems complicated, especially with 5 disks on here. A lot of little steps to make happen. It seems like it'd be very logical. Like so, if the disk is on top, move it to the open one, and then if you try and specify the rules, it'd be difficult. And this is one of those cases where I challenge the recursion believers that recursion is natural. I don't know that the solution to this is natural in somebody's head. It's going to pop out. I mean, you might play with it and get a gut feel for it, but whether you can just say, oh, yes, it's quite simple, I'm not sure. And let me tell you, the code for this is elegantly simple. So what we're going to write is actually code that's going to give somebody instructions for this. I'm not going to go make animated disks to move around for you or whatnot. You could, but that's not the goal. We're just going to simplify it and just say we're going to write instructions. For example, take disk 1 and put it on the support post. Take disk 2, put it on the destination post. Take disk 1, put it on the destination post. Something like that. And here's the code. I'm just going to show it to you to get started. We're going to write this in a little bit, but there's the code. It's not very big. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code, really. I mean, it's with some stuff split across 2 lines for space. But 10 lines of code to solve not just this problem with any number of disks. You can do 5, 6, 7 disks on top of here. It can work. So the question's not what does this do, but what the heck does it mean? How do I solve this problem? I mean, if you look at this, there's a couple recursive lines, and there's actually two methods inside of here, and I could eliminate one of them. The first several lines of code I could eliminate by just having a nasty call for people to understand to come in. But it comes down to the same idea of creating a base case and figuring out the recursive cases that get down to the base case. All right, so the base case really is I have the top disk, and it needs to be moved to the final destination, disk number 1, the smallest disk. That's really what comes down to the base case. Everything else is coming down to moving disk 2 or 3 or 4 or however many disks there are to some other desirable destination. So the recursive case is really basically a call to move everybody on top of me to another place, move me to the support post, move me to my destination post, and then move everybody on the support post on top of me, which makes sense to some degree, right? So if I have a stack of books and that's sitting on my chest, what I want to do is move all the books off my chest, move myself to another place, and then put the stack of books back on my chest. For whatever reason, I would have a stack of books on my chest, but you understand I'm making myself one of the disks in this case. So when you can see the problem like that, it becomes somewhat simple, but how do I see the problem like that? Well, let's look at this. Let's look at how this breaks down, and maybe you can understand how the solution is so elegant and simple. So let's do a 3-disk problem. So I want to move 3 disks from the starting post to the destination post. So what I do is I say, okay, I want to get this set of instructions where you tell me to move disk number 3 from the start to the destination using the support one. So this is the starting location, the final location, and the support tower. Now, there's some interesting quirks here because what I do essentially is I'm going to say, well, to move me, number 3, over to here, well, I got to move everybody above me, starting with this number 2, to the support tower. All right, so this first call really points down to moving this to this middle one. So I'm switching my destination support tower right here. And then from there, I'm moving disk 1 on top. So again, like I was just saying about moving off my chest, I need to move number 3 to destination. So before I can do that, I get everybody off to that support tower. And so all I have to do is call myself where I just switch the destination. So let's look at the work for moving 2 real quick. So again, we say, well, we want to move the 2 disk from the starting point to the destination. And so again, we say, well, let's move disk 1 and just swap the definitions of those. So if in our head as humans, A is the starting post, C is the destination post, that kind of locks that information in our heads. But remember, the rule of recursion is we don't care about anything except for our call. The fact that the destination post is C in the bigger problem means nothing for the destination post when I'm solving the smaller problem. So in this case, when I'm just doing the 2 post problem, I switch the destination post without any worries. And thus, when I get to the second call, moving 1 from the starting post to the support post, well, that just simply says, hey, by the way, that's our base case. So I can set the destination post to be here, because I switch those definitions, and then move 2 to the destination, and then, as I said, move the ones that were on top of me before back onto me. So I don't need a bunch of if decision logic when I have very simple rules that are fundamentally iterative. My data structure is fundamentally iterative. Every disk is either on top of another disk or has a disk on top of it, except for the top one, which is the smallest one, and then that's the base case, right? Um, and so since we have this recursive data structure, we can go move and build it around like that. So let's take a moment and let's check out this code and let's do it in code. There's a problem out there is set up for you to get started. So you can see Hanoi here. And again, we have this idea of creating the instructions. And so when we have the idea of creating the instructions, this is a helper method to the recursion. It's really a starting point where the user doesn't have to understand what starting points, destination post, and everything else like that. So we might have those defined somewhere for us, but we're just saying like, okay, we'll create instructions for some number of disks, right? And so we're going to end up with a list of instructions here that we're going to add in here. And so our list of instructions is going to come from this base call. So again, this code up here is just a helper for the user to have a clean interface. It's not necessarily required, but this is going to be adding instructions. We're going to call our recursive call. This is going to be our first call to that, where we need to pass in the number of disks, which is passed into us. And then we need to find the first post and the second post. So we're going to go from the first post, that's going to be our starting post, to the final post. I'm just going to copy and paste these, by the way. That's why I'm double clicking this and hitting Control C. And then our support post is going to be the middle post right here. And then we're going to pass along our instructions that are going to get filled over time. So I'm not going to return anything because that makes it slightly more complicated. I'm just going to pass along the instructions. By the way, if you want to tackle this on your own, feel free to pause this video, come back to it. You don't have to. You can follow along here, or you can try it on your own and come back to it later on. But I just want you to understand what this helper method is from there. So this is just simply a call to not have the user have to worry about these names and this instruction set and whatnot. And so I just return the instruction set. So now we're getting to the actual recursive call. Okay. So here's the place to pause if you want to go work on your own. All right. So the base case. Well, remember the base case is, well, if the current disk to move, so if that is equal to disk 1, right? So if we start with the smallest disk, which we get to define, by the way. So since I say number of disks, I could check up here if number of disks is negative or 0. I can throw errors. Again, keeping it simple. But since I have that helper up there, I can know theoretically in this method, if I check it up above, that I know this is going to be 1 or greater. So what we're saying is the current disk to move is equal to 1. Well, if that's the case, then what do I want to do? Well, I want to move the disk. So I'm going to add the instructions here. Add to the instructions. I'm going to add an instruction. And what's my instruction going to say? Well, it's going to say, oh, yes, by the way, I have a move message template here. So I can format on this template. So what it's going to say, move disk, first disk from post 1 to post whatever. So, well, the disk we just got is the current disk to move. And I'm moving it from the starting post to the destination post, right? That's the base case. So I'm going to copy this right here. Just make sure I type it in right. And destination post, copy this right here. And there is our base case. So I'm going to go ahead and just run this. Oops, invalid syntax. What did I forget? What did I forget? Probably missing, if it's right here, I'm probably missing a parenthesis. Yes, missing a parenthesis. Number of disks is not defined. Number of disks. S. All right. Result not about to expected. You returned 0, but I expected 7. Oh, shoot. So my tester's not doing something. Well, that's okay. I can print instructions. Oops. Instructions. I'm not making things plural today. Oh, I have no instructions returned. Oh yes, because I'm passing in too many of these. I'm passing it in for my test case is for a 3-disk solution, right? Yeah. So let me just pass this in for 1 real quick. All right. So move disk 1 from post A to post C. Yes, got it. So that's my base case. Make sure it's working. So don't forget, I can always go through and tweak my test cases to make sure stuff's working, and I can work on it a little bit at a time. So excellent little helper right there. All right, so what's the recursive case then? All right, so if it's not the base case, then what do? Well, very simply, I'm going to add some instructions. So I want to, if I'm greater than 1, well, I want to take the current disk to move minus 1, the one on top of me, right? And I want to move that one, well, I want to move that one from my starting post to where? Well, the support post. Using the destination post, right? And passing the instructions. So if I am not disk 1, then I want to get everybody off of me so I can move to where I want to go. Make sense? And so after I moved everybody off of me, well then I'm going to add an instruction to move myself. So I'm going to move the current disk right there from the starting point to the destination point. So that template holds up exactly as before. So if I'm the first disk, I go to the destination point. If I'm not the first disk, I move everybody on top of me, then I go to my destination, the place I want to go to. But then after I move myself, if I really want to be the full tower, well, I need to add the instruction to move, well, again, I got to take that one that was on top of me. So this one, I'm just copy this actually. The current disk on top of me. Well, I want to move that one from the support post where it was to the destination post. They're not on top of me anymore, right? So where they went, where they ended up, I want to move them on top of me using the starting post. All right. So logically speaking, hopefully this makes sense. Starting there. At least I have some authenticity of this because I would keep spelling things wrong. Ooh, recursion, maximum recursion depth exceeded in comparison. So what did I do wrong? I did something wrong here, and I'm not sad about that, right? Maybe it would have worked the first time, but by having something wrong, it gives us something to go and look at. So what I'm going to do here, this video is getting a little bit long. I'm going to pause it. Maybe we're going to finish it in 2 minutes in the next video, but I want to leave it here for you to maybe take this and play with it. Maybe see how you can see what we did wrong or what it's probably a simple typo. But we'll talk about in the next one, how do we debug it? How do we sort it out? How do we make it work? And so we'll come back and do that in just a second.